This is chapter 22, example 3. And so what we're doing here is designing a interesting little circuit. And the issue here is it has some issues with this circuit that you may not initially see, but as you work through the problem, typically you'll figure it out. That's generally the design approach for digital design. It's not linear. Just crank through it, don't get stuck, and when you need to go correct something, just go back and correct it. All that matters is the final circuit. It doesn't really matter how you get there. There's a whole bunch of different ways to do this circuit as well. I'm going to choose one way, the way that makes the most sense to me, and certainly it highlights some of the underlying details of this thing. Now, this is a circuit where we are adding two 8-bit values. They're in RC format. We're accumulating them. The issue is if they're both positive, they're equal, then we accumulate them. Otherwise, we don't accumulate them. Now, the issue is with the circuit, there's two approaches to this. And I'm going to take the dumb guy approach on this one. Now, the issue with this is that it's sometimes we add the summation and sometimes we don't on a clock edge, but that's not really the way to look at it. The easier way to look at it is to add the number when we need to and add a 0 when we're not supposed to add the number, and doing that simplifies the circuit. And the notion is that adding 0 is essentially not adding. And we'll take advantage of that when we do this problem. You'll see that come up a little bit later. So the first step in the problem is to draw a black box diagram. Next step in here, we're going to take an inventory of the parts we need in here. And obviously we are accumulating something, so we need an accumulator. So real quickly, I'm going to draw an accumulator for this. And that is our accumulator. Notice that this problem resets when it generates a carryout. Now the first issue we have to worry about here is we said when we're dealing with RC numbers that we have to use a valid circuit, like checking the sign bits to see if it overflowed, but this is a special problem. If you read it carefully, you see that the circuit adds both values only if they're equal and only if they're non-negative. Essentially, we're adding positive numbers. So in that being the case, it's essentially we're working with unsigned binary at this end of the circuit, and so we can use the carryout on the ripple carry adder here to handle the overflow. And so the overflow is connected to the clear, and we want to put a note up here. The clear is asynchronous, and so the next part in the circuit is we want to add those two numbers, the two 8-bit numbers, and output that to what we're accumulating here. So we're going to output the sum of those 8-bit numbers to the accumulator. There's different ways to do this. I'm going to choose to, at the beginning of the circuit, bump this up to 12 bits. So I'm going to put a note in there and do this. Adder there. I sign extended it by 4 bits. I put notes in there and I indicate it in the diagram. So the sum of those two A and B input values is what's going to be accumulated. It's only going to be accumulated under certain conditions, and I already noticed I made a mistake in here, so we'll have to go fix that. So the issue is it's going to be accumulated when certain conditions are met. Now the conditions are they have to be equal and the numbers have to be positive. Right there we have an AND gate that's controlling this thing. So we'll put it in there. There's our AND gate. And so what we messed up here is it's just the output of this gate here is what is going to, the output of this gate is controlling this mux. The mux is either adding the output of the sum or it's adding 0. That was what we agreed on when we first started this problem. So initially we haven't done anything on this mux yet. We haven't put the numbers in. We don't have to worry about that. We'll worry about that in a minute. So the other part of this problem, there's two other parts to it. One is the numbers have to be equal. And so I will drop a comparator in there. And we can compare, we can make an 8-bit comparator. There's our equal. And the last thing here is these numbers have to both be positive, which means the sign bit on these numbers have to both be 0. Now the easy way to do this is they both have to be 0. One and the other has to be 0. I'm going to indicate that with this AND version of a NOR gate. So this is the other condition for this AND gate up here. What we're going to do is connect this to... These are the sign bits of the two input values. I think I'm done with this almost. I need to put these 1s and 0s in there. And so I'm thinking that when this output of this gate's a 1, that's when I'm going to do the add. Otherwise, I'm going to do add 0. I'm always going to add, but I'm adding 0 sometimes. The issue on this one is, I think I'm done on this one. So I guess there's no issue. Okay, so what controls this circuit? We got a mux here with control input, and that makes it internal control. And do one final check over this problem here. Oh, we have these are both control inputs as well. They're both internal, so we don't have to worry about that. And at this point, I make sure this is done. I would call it done at this point.